These are notes from section 6.2 on multiplying and dividing radicals, as well as 6.3, which is on adding and subtracting them. We have two properties here in section 6.2. Both of them are very similar. It says if the nth root of a and the nth root of b are real numbers, then I can multiply the nth root of a and the nth root of b by just multiplying their radicands and keeping the index the same. Same thing if I divide. I divide the radicands, the index stays the same. So the cube root of 2 times the cube root of 3, I just do 2 times 3, gives me the cube root of 6. Cube root times cube root. Notice the index has to be the same. Same thing works if we're dividing. So example 5, I guess, should be example 1. Asks us to completely simplify the cube root of negative 5x times the cube root of 27x to the 7th. Because they're both cube roots, I can just multiply what's under the roots. Negative 5 times 25 is negative 125. X times x to the 7th is x to the 8th. Cube root of negative 125 comes out even. Even though 8's not a perfect, or is a perfect cube, x to the 8th is not, because 8 divided by 3 doesn't come out even. So we need to split it up the same way we did last class. I need a number less than 8 that is divisible by 3. That number would be 6. It's the closest one to 8. And then to get x to the 8th, I need x squared. X to the 6 times x squared is x to the 8th. Cube root of negative 125 is negative 5. Cube root of x to the 6, 6 divided by 3 is 2. And the cube root of x squared doesn't come out even, it stays under the root. So really the only thing that's new is step 1 here, where we multiply them together. We did the rest of this last class. Part B, mistake here, that should be an A and a B. Part B, we need to start by multiplying. 54 times 5 gives me 270. A squared times a cubed is a to the 5th. B cubed times b to the 4th is b to the 7th. I need to split this up. 270 is not a perfect cube, but it has a factor of 27, which is 27 times 10 gives me 270. 5 divided by 3 does not come out even. Let's change it to a cubed times a squared. 7 divided by 3 also does not come out even. B to the 6th times b to the 1st. (27) is a perfect cube. A cubed is 3 divided by 3 is 1. 6 divided by 3 is 2. And the ones that didn't come out even are 10a squared b. Example 2, very similar, but now we're dividing. The cube root of 32 divided by the cube root of negative 4. I can just do 32 divided by negative 4 is negative 8, and then take the cube root, which is negative 2. Same thing on B, divide first and then simplify. 162 divided by 3 is 54. X to the 15th divided by x to the 5th is x to the 10th. 54 has a factor of 27. 10 divided by 3 doesn't come out even. I need to make part of it so it comes out even, and part of it doesn't. I get 3x cubed times the cube root of 2x. Next thing we need to take a look at is rationalizing the denominator. In order for an expression to be completely simplified, the denominator, the bottom, has to be rational, which means it does not have a root in it. So example 3 here, part A, we are given root 2 divided by root 3. Root 2 divided by root 3. 2 divided by 3 doesn't come out even. If it does, we're just going to do it like this, where we divide it and then take the root. Divide it and then take the root. Problem is 2 divided by 3 does not come out even. So we want to multiply the bottom by something so that the bottom does come out even. I need a perfect square that has a factor of 3. The smallest one is 9. I can get root 9 by multiplying root 3 times root 3. If I multiply the bottom by root 3, I have to multiply the top by root 3 as well. Root 2 times root 3 is root 6. Root 6 does not reduce. Leave it alone. Root 9 is 3. Notice I no longer have a root on the bottom. Part B, I've got square root of x cubed divided by square root of 5xy cubed. First thing we're going to do, just like any other division ones, we're going to divide anything I can first. And the whole thing doesn't divide, but x cubed divided by x does come out even. It's x squared. 5y cubed. I don't have anything to combine that with. I'm just going to leave it as 5y cubed. I have a root on the bottom, so I need to rationalize. I need to multiply it by something so that the bottom comes out even. 5 times 5 will give me 25. Y cubed times y would give me y to the 4th. Y to the 4th is the smallest that I can make this so that it comes out even. If I multiply the bottom by root 5y, I have to multiply the top by the same thing. So on the bottom, I have 5y squared. No root, that's good. On top, square root of 5 can't be simplified. Square root of y cannot, but the square root of x squared is x. So I have x square root of 5y in the numerator. These are under the root, these are not, so even though they have the same variable, I cannot simplify those in any way. Part C, we are dividing cube roots. 9 divided by cube root of 4. Cube root of 9 divided by cube root of 4. 9 divided by 4. I would start there. If you can divide them and they come out even, it's easier than trying to rationalize. I want to multiply by something here so that it comes out even. With square roots, usually you can multiply it by itself. 3 times 3 is 9, so square root of 9 comes out even. 5 times 5 is 25, square root of 25 comes out even. 4 times 4 is 16. 16 is not a perfect cube. So you're not always just going to automatically multiply it by itself. Instead, we want to think through what perfect cube has a factor of 4. We want the smallest one. The smallest one would be 8. The cube root of 8 comes out even, so I need to multiply 4 times 2. And if I do it on the bottom, I have to do it on the top. Cube root of 8 is 2. My denominator is rational. 18. Perfect cubes are 8, 27, 64. None of those go into 18. We're just going to leave it as cube root of 18. It cannot be reduced. 6.3 is on binomial radical expressions. Binomial meaning two terms. Radical meaning it has a root in there, a square root or a cube root. I don't know why there's all this space, but we just multiplied and divided radical expressions. In order to do so, remember they need to have the same index. It's got to be a square root times a square root, or a cube root times a cube root, or a ninth root times a ninth root. If they don't have the same index, we can't simplify it in any way. But the radicands do not need to be the same. In order to add or subtract, not only does the index need to be the same, but the radicand needs to be the same as well. The coefficients don't have to be the same. So I could do 5 times the cube root of 2 plus 2 times the cube root of 2. So the index needs to be the same. They both have to be cube roots, and the radicands need to be the same, the thing under the root. But again, the coefficients, the things out front, do not have to be the same. So let's take a look at how we would do this. Here we're given 5 times the cube root of x minus 3 times the cube root of x. Notice indices are the same. The index is the same on both. The radicand is the same on both. So I can combine them. We're just going to combine like terms. Here I've got 5 cube roots of x minus 3 of those cube roots of x. So I have a total of 2 cube roots of x. Just like if you did 5x minus 3x, you do 5 minus 3, but keep the x. It's the same thing. Part B, what if they give it to us so that it can't be combined? At least not as it's written. Six root 18 plus 4 root 8 minus root 72. We want to start by reducing the roots. We cannot combine them as it's written because the radicands are not the same. So 18 is 9 times 2. Here I have 6 times 3 times root 2. I've got 18 root 2. Root 8 we would reduce as root 4 root 2. Square root of 4 is 2. So I've got 18 root 2 plus 8 root 2. 36, the easiest way to simplify that would be 36 times 2. So reduce the roots, and then any of them that do have the same radicands you can combine. So here I've got 18 plus 8 root 2's. That gives me a total of 26 root 2's minus those 6 root 2's. So I have 20 root 2's. Let's do one where we're combining cube roots. Radicands aren't the same. We want to reduce them and try to make them the same. Factor of 40, that's a perfect cube, is 8. $135 is 27 times 5. Cube root of 5 does not reduce. Two cube roots of 5 plus 3 more cube roots of 5 give me 5 cube roots of 5 minus 1. So I have 4 cube roots of 5. And then last thing, if we are asked to multiply two binomial radical expressions, a binomial times a binomial, we FOIL. So here we do 3 times 2, 3 times 4 root 5. You multiply those, you multiply the coefficients, it's 12 square root of 5. So 2 root 5 times 2 is 4 root 5. 2 root 5 times 4 root 5. 2 root 5 times 4 root 5. 2 times 4 is 8. Root 5 times root 5 is root 25. Here I've got 6. These two are like terms. I can combine them. 16 root 5. This is 5 times 8, which is 40. So I get 46 plus 16 root 5.